Okay, hello everybody. Today we're going to go over pneumatic cylinders and throttle valves. I put these two items together because they work very closely together in our systems. So I just want to make sure that we all have them on the same page so I could show similar examples of them just so it makes more sense. So first off, in the cylinder world, these are two forms of a cylinder. They come in many form factors, so you can see these pneumatic cylinders in all types of different looks, shapes, sizes, whatnot. But primarily we're using two of them in class. We're using a double acting cylinder and a single acting cylinder with spring return. Now, parts of the cylinder. So you have the piston, which is in here, which has where the air pressure pushes on either side. And then you have a shaft, which comes up through the middle of it, and it's connected to the piston, and that goes out or back. You also have the cylinder itself, which holds in the air, and then you also have ports right here and one right here, and that's where your air is going to be going into. So for our double acting cylinder, we have two ports, which means that we can control when the air comes in and when the air comes out. So we can control if this is going out or if it's going in just by using valves to put air on either side of the cylinder. Now with the single acting cylinder with spring return, we can only really put air in one side. There's only one port. So we can only control when this is going to extend. We can also tell it when to come back in, but we have no way of giving power to this side because it's just a spring return. It's going to go back on its own. We can't say how fast we want it to go back unless we use a throttle valve in a different location, which I'll show you after. But primarily you got one valve, one port that can do work out here. Now, what happens if we put air on either sides of this and it's in the same location, right? So our piston is in the middle. If I put air on both sides of the cylinder, which way is our shaft going to go? And we have to think about area on our piston. So for instance, the area for A, which is right here, this is kind of like a cutaway, is a lot more than the area for B because we have a shaft going up through the middle of it. So ideally you're going to see the same amount of air coming in here and here, but you're going to see that the A side is going to push all the way to the out this way. So if I hit the button, you can see that happening, right? Now on the other side here, we have a shaftless cylinder, and we can kind of see which way the air is going to go, right? So if we think about it, both sides are basically A, so they both have the same area. And I made sure that this the cylinder here, the piston, is right in the center. So when I hit the button, it'll stay right there in the middle. So we got to think about that when we're writing programs and controlling these cylinders. You don't want air fighting air because you could kind of figure out which way it's going to go, but you're kind of wasting energy and stuff. So we want to just be careful when we're programming not to have two solenoids go off at the same time that are hooked up to valves that are going to be blowing air in both sides, especially if you're worried about safety, which we all should be when we make these programs. We want to make sure that we know what's going to happen when we hit the red stop button. We want it all to retract. We don't want it to go forward and crush more stuff or crash harder. So just think about that when we're programming, which way the air is going to push in there. Now, on the other side of it, we have throttle valves. And I got some examples here about throttle valves. But primarily we have a variable throttle valve and a variable throttle valve with a check. Now, the variable throttle valve, which is just this one right here, you can basically tighten this knob here and it will restrict the airflow through. And why we do that is that you can control how fast our cylinders move, how fast they retract or extend. And when we use just the variable throttle valve, it's the same restriction for the air going in and also out. But when we talk about a variable throttle valve with a check, you have a check now, so the air coming in this way will be restricted by our throttle valve, but the air leaving the cylinder should pass right through here. And this is actually, if you were to take a bandsaw and cut one of these variable throttle valves right in half with a check here, you would see that there is a cone with a bearing, and that's what causes the air not to come through and bypass our throttle valve here. It actually comes in, pushes up against the bearing into the cone here, and then it forces the air to come through this. But when the air is pushed out the other way, it easily pushes the bearing out of the cone, which lets it blow out through there. And I could show you some stuff here. We have 2 examples. So this is, I just want you to see what the speeds are here. You can see the one down here is going a little slower, and that's because it has 2 variable throttle valves, and these have 2 variable throttle valves with checks. Air here can pass freely out, so that means it can go to full force. Nothing's restricting it. This one, on the other hand, is being restricted both ways, but we can change it and just see what happens here. We'll go full. It moves a little quicker that way. And that's variable throttle valves and pneumatic cylinders.